All right, hey gang. So we're moving on with our graphing now. So we've graphed sine and we've graphed cosine. And so now we're going to move on to graphing tangent. Okay, so then we'll have the graphs of sine, cosine, and tangent. So with tangent, let's generate the graph the same way that we did with sine and cosine. We'll use the unit circle. So if we want to get the graph, we'll make a table. All right, we'll go from negative 2 pi to 2 pi. And we're going to use the fact that we know tangent is sine over cosine. And we know that sine is the y value on the unit circle and cosine is the x value on the unit circle. So we're going to use all of this to help us go through and generate and come up with points. So to get started, we know this point on the unit circle here is the point 1, 0. So negative 2 pi hits there. So if we want to find the tangent of negative 2 pi, it's going to be the same as the sine of negative 2 pi over the cosine of negative 2 pi, which is going to be 0 divided by 1, which is 0. And then you're going to continue and go through and find all of those, and then we're going to plot these on the axis, okay, xy plane. So take a second. And go through and do those. You're going to see pretty quickly that there's a pattern. Okay, so I've gone ahead and got our XY axis there. We've got our unit circle. You know that this is the point 0, 1. This is the point negative 1, 0. This is the point 0, negative 1. All right. So tangent of negative 3 pi over 2 puts us up at the top. So we're going to get 1 divided by 0, which is undefined. And then what you're going to see is that this basically just alternates. We get 0, we get undefined, we get 0, we get undefined, we get 0, we get undefined, we get 0. So in all of the increments of pi, we get 0. The output is 0. So we know that the graph at least touches or crosses there. And the question is, what do I do with all the undefineds? Well, if we remember when we studied rational functions, so for instance, if we had a rational function, something like this, 1 over x minus 2, you know that if I was to plug in a 2, we would get 1 divided by 0, and that would lead to a vertical asymptote. And so the same is true on tangent. At all these places where the denominator ends up equaling 0, that is the indication, when we get the answer undefined, that's the indication that we have a vertical asymptote. Okay, so we have a vertical asymptote at negative 3 pi over 2, vertical asymptote at negative pi over 2, and so on. This continues, okay? And it goes forever. So every incrementation of from pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, on those, we're going to get vertical asymptotes. And then now the question is, well, what's the graph doing? So we know the graph has to approach this somehow. So if I plug in pi over 4 to see what happens, if I wanted to do a tangent of pi over 4, so if I'm going to do tangent of pi over 4, that's the same as doing tangent of 45 degrees, and we get the answer 1. So I know that it has a point up here at 1. So thus it's going to go like this, okay? And then if I try negative pi over 4, so on this side, so if I plug in negative pi over 4, which is tangent of negative pi over 4, which is tangent of negative 45 degrees, and if you were to work this out, you would get negative 1. That's the fourth quadrant. Tangent is negative in the fourth quadrant. So there's that point. And what you'll see is that this just repeats over and over. That repeats over and over. So tangent is not a wave, so it is not a wave, right? Because of all the discontinuities. All right, so therefore there's no amplitude. But for basic tangent, it is pi periodic. It means it repeats itself every pi. So if you look at the cycle, here it's crossing at 0, and we go an incrementation of pi, it repeats. So tangent's pi periodic, okay? What else can we say? So for one cycle, we're just going to keep the part from negative pi over 2 to pi over 2. So I'm going to draw that over here in just a second. Oh, let's just step away so you have the whole picture there. That's everything. There's the entire tangent graph. So what we're going to do, we'll just save the one main cycle, which we can see is right here. If we just copy and paste this forever, we will get the entire graph of tangent. So we're going to keep that, okay? So what I'm going to do, I'm going to go ahead and erase now. And on this side over here, we'll store our one cycle. And then we're going to look at how does, numbers in the equation affect that graph, and then how do we graph that. So we're going to store one cycle for y equals tangent. We're going to memorize that from negative pi over 2 to pi over 2. And looks like this. So negative pi over 2, vertical asymptote. And pi over 2, vertical asymptote. And then it kind of squiggles through right there. There's your graph. Okay. So now, what we want to look at are the transformations. What happens with all the specific transformations? Well, it's going to be very similar to what happened with sine. So what we want to look at now is what happens if we have a times tangent of bx minus c plus d. Well, what does the a do? Right? On tangent, it affected the y's. Well, still, it's going to multiply y values by a, and we know also if a is less than 0, it's going to flip about x. Okay, so we're going to make that note. So for instance, if I was asked to graph 3 times tangent x, well, what's that going to look like? Well, I know my main one cycle goes negative pi over 2 times pi over 2. Right, and here's my basic graph. Well, I know that it's going to stretch by a factor of 3. So that point there is going to be 3 times higher than it was. And this point here is going to be 3 times further from there. And then I'll just simply go and make like a stretch. Okay. So I'm not really plotting points. I'm just going to stretch it. So that's if I have a number, say, greater than 1. What if I had a negative 3, right? Well, if it's a negative 3, then we know that it's going to stretch, but it's also going to negate, so it's going to flip. So I would draw something like that, okay? So that's how I handle the number in front. So notice, still my only point that I'm really dealing with is that point there, okay? Then let's say, what if we had negative 3 tangent x and then a plus 2 at the very end? So we're talking about the d, okay? D, what did it do for sine and cosine? We shift up or down d units. Well, same thing happens here. We would take that picture, we would move it up 2. So that point that was at 0, 0 is now going to be at 0, 2. There's that point. Okay. All right. So now the big question is, how do we handle this? You're going to handle this the exact same way that I taught it with sine and cosine, okay? Except for tangent, a cycle starts at negative pi over 2 and ends at pi over 2. So we'll erase this example problem here. let's just say we have something like y equals tangent of 4x minus pi. We want to graph that, okay? How do we deal with that? Well, we're going to take the inside, our 4x minus pi. We're not going to set it equal to 0 and 2 pi because that's not where tangent cycle starts and ends. We're going to set it equal to negative pi over 2. And we're going to take 4x minus pi and set it equal to pi over 2. So we're going to set it equal to where the tangent graph starts and ends, and then we'll solve. So if I wanted to be able to graph tangent of 4x minus pi, I've got to be able to handle that. And again, this is the old start, and this is the old end. Okay, same ideas that we use for sine and cosine. All right, and so I'll solve. So let's see. So we'll do 4x equals negative pi over 2 plus pi. So we'll get 4x equals pi over 2. You get a common denominator of 2 pi over 2. And then I'll divide 4 by 4. Well, instead of dividing by 4, I'm going to multiply by a fourth. So I get x equals pi over 8. Over here I add pi, which is the same as 2 pi over 2. So 4x equals 3 pi over 2. And then again, if I divide by 4, it's the same as multiplying by a fourth. And we get 3 pi over 8. And so now, if I want to draw tangent, I can kill two birds with one stone. Now I know two things are going to happen. It's going to move right and it's going to horizontally compress because I can see it starts at pi over 8 and it ends at 3 pi over 8. So I'm going to basically copy and paste my picture from here, copy and paste it here. So starts with the asymptote, ends with the asymptote, and the middle is an asymptote. Or I'm sorry, the middle is the graph. And then we could add more cycles if we wanted. If I wanted to put the next one, of course, the asymptote would be at 5 pi over 8 because I can see every 2 pi over 8 there's an asymptote starting at pi over 8. And then I can put another one. You could keep going. You go 2 pi over 8 this way, so 1 pi over 8, another pi over 8, put us at negative pi over 8. And you could build from there, but really, if you just want one cycle, that's it. Okay? And that's graphing tangent as an extension of what we did for sine and cosine. So so now we know, what do? We said bx minus c equal to negative pi over 2, and bx minus c equal to pi over 2, and we solve for x, and that allows us to get the start and end, okay? That's our start and end of cycle. The other thing is, notice there is still periodicity for tangent, means it repeats. The period, if you want to find the period, is pi over absolute value b, because tangent's pi periodic. So if I wanted the period for this one, the period for this graph, right, it's going to be pi over b, which is the coefficient of x, pi over 4. So let's see if that's right. So we started at pi over 8. We went 1 pi over 8. We went another pi over 8, right? So pi over 8 puts us at 3 pi over 8. That's the horizontal distance for the cycle. Well, how many pi over 8s? That's 2 pi over 8s. 2 pi over 8s is pi over 4. Okay, there's your period. Okay. All right, we'll do one more, and then again, I'll create a little homework assignment for you, and we'll go from there. All right, so let's do one more of these. I'll save that. We'll erase this, and we'll do one that has a little bit of everything. All right, so I guess this is really our example 1. So given y equals negative 2 tan 2x plus pi minus 1. So now we have a little bit of everything. All right, we're going to sketch one cycle. Now, you're welcome to use your calculator, but you're going to see on your calculator it's very hard to see where that one cycle is, very hard to find the asymptotes and so on. I always go left to right in my order here. So I'll handle this vertical stretch, I'll handle the horizontal movement, then I'll handle the vertical shift. So if you want to pause here and give yourself a chance to see if you can sketch the one cycle, pause it, and then you can unpause to check, okay? So let's see. All right, start with the basic graph, negative pi over 2 to pi over 2. All right, so let's deal with the negative 2 first. It's going to stretch it, right? But then it's going to flip. So it's going to become like this. Oops, still should go through 0, 0. And right now that's negative 2 tan x. So notice as I handle each transformation, I should slowly regenerate this big equation that we have. Then the next step is we take our 2x plus pi, which is our inside, we set it equal to negative pi over 2. And we take our 2x plus pi and set it equal to pi over 2. We're going to solve for x. All right, so I'll subtract pi. So 2x is negative 3 pi over 2. Again, common denominator. And then if I divide both sides by 2, it's the same as multiplying by a half. I get negative 3 pi over 4. Here, we subtract pi. 2x is negative pi over 2. Divide by 2. X is negative pi over 4. So that's where this graph is going to start and end. So I need to draw it from negative 3 pi over 4 to negative pi over 4. Okay, so right now I'm out of room, so I'm going to go ahead and erase this. All right, I'm going to take that picture that we just had and I'm going to draw it. So here's negative pi over 4. There's another unit, there's negative 3 pi over 4. And tangent always starts with the asymptote and ends with the asymptote. So I just copied and pasted and put that picture there. And so right now this is negative 2 tan 2x plus pi. And then the last step I think is the easiest, the minus 1. We just shift down 1 unit. I can erase. There I go. Okay, that's it. All right. One last type that I see students, so sometimes they'll struggle with this. We'll do one more. And I think they make it a little bit more difficult than what it is. And let's just say, here's our basic graph here that we have. And we'll call this example 2. And let's just say we have tangent of 10 pi x. Okay, nothing else on the inside. So that tells me that it's going to stay symmetric about the y. All right, it's going to stay symmetric about the y. It's either going to stretch or it's going to smash or horizontally. But it should still have that y-axis, this symmetry here. It's actually symmetric about the origin, right? So all I have is the inside. So I take the inside, set it equal to the start, and I take the inside and set it equal to the end, okay? Well, the only thing, since there's no plus or minus for the x, all I'm going to do is divide by 10 pi, which is the same as multiplying by 1 over 10 pi. But when I do that, the pi's cancel, and I get negative 1/20th, all right? Same thing here. I'm going to divide by 10 pi, which is the same as multiplying by 1 over 10 pi. Pi's cancel, and I get 1/20th. So notice that the symmetry is the same. Now 1/20th is very hard. 1/20th is here, negative 1/20th is there. It's very hard to draw that. So what I'm going to do, if I have a good eraser, I'm just going to erase this, make this negative 1/20th, make that positive 1/20th. There I go. And there's my graph. Okay. All right. So in a nutshell, this is the lesson on graphing the transformations of tangent. And hopefully this is helpful, and this is an extension of what we've done there with sine and cosine, and I'll also send you a short assignment to do. Okay, good luck with that.